Welcome to Sairam Tribal YouTube channel. Let us discuss continuation of previous video, Van de Graaff generator. I'll be giving some brief explanation for Van de Graaff generator. Already we discussed this Van de Graaff generator. So Van de Graaff generator, which is used to generate high voltage, whatever the so positive ions, whatever we are injecting here, it will be spreading here to here and here to here. So the electrons will be, whatever the positive charges will be spreading over the surface of the, surface in the sense the in the sphere the potential will be increases. Like, so voltage whatever present higher to lower potential, everybody knows. So the it will be spreading over like this. So this is a concept already we discussed. And the shape of the electrode are spherical. Already I told you that's a spherical electrode, okay. And the charging of the belt is done by the lower spray point, which are sharp needles, okay, connecting to DC source about 10 to 100 kilovolts, so that current is maintained between the moving belt to the needle. See, the whatever we are spraying of electric charges into the belt, so that belt and the maintenance of voltage till the sphere. So it is depends upon the depends upon the voltage, and also the corona is corona maintenance in the moving belt to the needles. Belt has a self charging system. Belt is also having a self charging system for the movement of this one positive charges. So next we will discuss Cockcroft-Walton type high voltage DC set. So we have a in the Cockcroft voltage DC set, we have cascade voltage multiplier circuit. Voltage doubler circuit. In the previous class, in the second video, we discussed voltage doubler circuit, right? So here we are having a number of voltage doubler circuits. Cascading of voltage doubler circuit. So it gives you the voltages n times of supply. So for higher the voltage are difficult, so required too many supply isolating transformers is required, and it is possible to generate very high DC voltage from the single supply transformer by the extending simply voltage doubler circuit. See here, the voltage doubler circuit gives you the voltages two times of supply voltage. Already we discussed, right? Similarly here, whatever the supply voltage are the doubler circuit, we are using n minus 1 types of supply voltage of output voltage, and it compared to input voltage. This is simple and compact when the load current required less than 1 milliampere, such as for a cathode ray tubes. So if it is if you consider cathode ray tubes, so it's less than 1 milliampere. Supply load requirement is less than 1 milliampere. So here wall type pulse generators may be used for instead of conventional AC supply. The circuit becomes very compact, compact with supply system. So this is a connection of Cockcroft-Walton type DC generator, and also DC set, right? So as you can see the diagram over here, 1 minute. So as you can see the diagram over here, there is a number of voltage doubler circuits present here, and we are giving supply is here. This part is voltage doubler circuit, single one, and after that if you take see here C1, C2 and C3 and C2n minus 1, C2n minus 3, C2n minus 1, C2n minus 2, C2n. So these are the not diodes, diodes only, but if you should consider as a rectifiers, okay. Cascade rectifier unit with the pulse generator. So P is the pulse generator, VB is the DC supply to pulse generator, which is the bias voltage, and D1, D2, C1, C2 are the transformer. T are the identical as the voltage doubler circuit. The condenser C4 is charged to 4 V max, and C2 to 2 N V max. above the earth potential, but the volt across any individual condenser or rectifier is only 2 volts max, right? So just to consider D1, D2, D1 and D3, D2n minus 1 conduct positive half cycle. So see here, only odd number gives you odd number of rectifiers conducts only positive half cycle, and D2 and D4 even number D2n conducts negative half cycle. So uh, see this part, this D1 and this D3, cross section, okay, D2n minus 1 conducts only positive cycle. If you give positive cycle like this, so only this one, and negative cycle, this D2 and D4 and D2n minus 1 conducts. So D2 and D4 and D2n is conducts negative half cycle, this cycle, okay, this cycle only, this part. So what happens, it gives output as 2 times of n voltage, 2 times of voltage. So DC power supply is about 500 volts applied to the pulse generator is sufficient to generate high voltages DC 50 to 100 kilovolts. See here, supply we are giving 500 voltage, but the output we are getting 50 to 100 kilovolts with a suitable number of stages will be there. And D1, D2, C1, C2 and the transformer T are the identical as in the voltage doubler circuit. The condenser C4 is charged, and 4 Vmax and C2n and 2n Vmax above the earth potential, right? See D1, D2, C1, C2, the transformer T are identical, okay, identical one. And but the volt across any individual condenser or rectifier is only 2 Vmax. So 2 times of maximum voltage. And D1, D3, D2n must conduct positive cycle. Already I told you D2, D4, D2n conducts a negative half cycle. And the calculation of output voltage, the pulse generator in the anode circuit of the valve P are rectified and the voltage cascaded to give the output across the load RL. So the output voltage I already told you 2n Vmax, right? A triggered voltage pulse trigger waveform ramp is given to make the valve switch on and off. So ripple content and voltage drop Cockcroft voltage type DC set. So first the calculation of ripple voltage, delta V is equal to the ripple I1 by FC, one big FC2. The capacitor already we know, right? I by C dV by dt or whatever. We got the derivation also. So I1 is the load current from the rectifier, F is the supply frequency. In general expression for a ripple voltage is given by N I1 by FC. So N is the N stage, the total ripple will be delta V total is I1 by FC 1 2 3 so on up to N I1 by FC N into N plus 1 by 2. N into 1 plus 1 by 2 is the sum of all the all the numbers. So 1 plus 2 plus 3 so on up to N is N into N plus 1 by 2. I1 by FC is as common. So the calculation of percentage of ripple, we have a percentage ripple delta V into 100 divided by 2 number, n is the number of this one units, and Vmax is the maximum voltage. 2n max is the output voltage for the this is output, okay, this is output part, this is okay. This part is output part, this part is delta V is a calculation of this part, okay. This part delta V is this one ripple, okay. This part of ripple delta V, the ripple I1 by FC2. If it is n number of stages will be there. Stage, don't confuse stage in the sense this one, okay. Stage in the sense number of stages 1 2 3, third stage, okay. This stage and this stage and then this stage, okay. So that we substituted over here, and we got the percentage ripple delta V into 100 divided by 2n Vmax. So let's solve the problem, okay. Let's solve one problem based on Cockcroft Walton type voltage multiplier circuit. So but we need formulas, this percentage ripple and delta V ripple and output voltage 2 nmax and I150. In the next video we'll solve the problem, okay, this problem.